Hello everyone, welcome back to Abdo channel. Today I'm going to start with a series of videos to implement the asynchronous communication with the servers and events approach. Okay, so before we start implementing that asynchronous communication, let's start with getting details about the synchronous communication. Okay, so in a typical application, right, when a middleware is running a RESTful web service, like it is suppose there is a transaction that is required for a client application to get the user details from a database, then a middleware will be exposing an API. That API will be getting data from the database, or it connects to any other backend systems like SAP or mainframe systems to get the data, required data, and gives it to the client, right? So in such scenarios, what will happen? Client makes a RESTful API call to middleware, then middleware uh, goes to the database, makes a SQL query to the database, makes another backend API call to the backend systems, and get the required data, and then it it processes the request data that it has received from the database, and it sends the response back to the client. So till the time middleware receives the request, until the time it sends the response back to the client, right, the client will be waiting to get the response from the middleware system. So it is all synchronous. Okay, so in this scenario where the client is trying to get the user profile data, and that will not be taking much more time, right? It is just a SQL query call or an API call to get the data from the database. So it may be getting completed within 5 seconds or 10 seconds. So client can wait for that much time, 5 seconds or 10 seconds, or maximum 30 seconds or 1 minute in a real world applications. But there are some scenarios, like if client wants to execute a specific job, okay, from the client system or the user interface application, then that job will not be getting completed within 1 minute or 30 seconds. So if that job is going to take I mean, the middleware is have to connect to the database or the backend systems repeatedly, and the job is going to take, suppose, some 30 minutes or 45 minutes or 1 hour of time. So the client has to wait for 1 hour, right? So which is not possible in the real world applications, uh, which is not seems good in the real world applications. The client should not wait for that longer, right? So suppose if there is a load balancer coming in between the client and the middleware, there will be a load balancer timeout of in general it will be set to 60 seconds, right? So that load balancer will disconnect the connections between the client and the middleware systems. Even though middleware is trying to get the data in the background, client won't be connected to the middleware. So in such scenarios, when client wants to execute a batch job, right, based on a request, then in such scenarios, the synchronous communication will not work out. So what we have to do, we have to go to the asynchronous communication approach. Like client will execute the job submission request to the middleware. Middleware accepts the request and sends the request back to the backend system, and it is going to process the request. Okay, but it just sends the acknowledgement response back to the middleware, and middleware sends the acknowledgement response back to the client. Right? That's all. It's only the acknowledgement. It's not the final response of the job, processing about the job. Right? All those things will not be given to the client application. So it's just an acknowledgement. Okay, so whenever client wants to know the updates of the job that it has submitted, then it has to do a periodical call to get the status of the job to the middleware. Whenever it gets the request from the client, middleware has to make a call to the backend system, and backend system responds with the response with the data to the middleware, and middleware responds with data to the client. So these calls will continue to happen repeatedly like this. Okay, client. I mean, the moment when I say polling, right? These calls can happen for every 10 seconds or 30 seconds in the period of time the job is going to complete. Let's say, for example, 1 hour. Then for until 1 hour duration, the job is going to, I mean, the client application is going to do the polling for every 10 seconds or 30 seconds to get the status update. Similarly, the middleware is also going to make the polling calls for every 10 seconds or 30 seconds to the backend system. Whenever it gets an update, it updates something in the, it updates that information in the middleware systems database or some files. Then when our client is pulling that information, then middleware don't have to go to the backend system, and then middleware gets the data from the file system or the backend database system that it has stored when it has received the response from the backend system. So that information can be given to the client whenever the client is polling for every 10 seconds interval. So this is what it is, right? So this is one approach where we are not making this call, the submission call, waiting. We are avoiding that with just an acknowledgement response. But this thing, client has to poll what happened to my job, what happened to my job. Like that, it has to poll for every 10 seconds to know the status of the job, whether the job is successfully completed or the job is failed, or what kind of reports the job is uh, generated. All those things the client has to know at the end of the day, right? So for to know that status, it has to poll for every 10 seconds or in the regular intervals of time. Okay, so this is one of the approach which has been used in the legacy systems to implement the asynchronous communications, the polling approach. But in the modern day systems, not we have avoided this polling by using the WebSockets concept. Okay, so here also the client will be submitting and the acknowledgement response will be given back to the client. But the moment when I say WebSockets, right, client will open a socket connection to the middleware systems. Middleware responds back to the data whenever it has received the data from the backend system, like this. Okay, so when I say WebSockets, right, it's not only the server can send the data to client like this. Whenever it has received the data from the backend system, it can send the push the data to that socket that is specifically open for that client. Okay, it's not only the middleware can send the data or push updates to the client, but the client also can send the required requests that if it requests for something more information about the job status updates, then it can also send another request, and the middleware can fetch the data and send it back. Okay, so it's always about the two-way connection. Okay, so whenever the client needs some data, it can send that request over the opened socket. Whenever the middleware has received an update from the backend system, it can also send the information that it has received from the backend system to the client over the socket that was opened for that particular client. Okay, so this is one of the WebSockets is one of the approach that we have to use when two-way communication is required between client and the server to implement the asynchronous communication. Okay, but there is another approach like asynchronous communication with SSE. SSE means server sent events. Okay, so in this approach also, the client is going to send a request, the job submission request to the middleware, and it will just send an acknowledgement request that your job has been submitted. Okay, after that, what the client is going to make, what the middleware is going to make, it middleware is going to make a connection open to the backend system. Okay, similarly, the client is also going to make a connection open to the middleware. Okay, then what happens, whenever there is an update from the backend system, it will be pushed to middleware. Okay, it's not that middleware is polling for updates to the backend system. It is that backend system, whenever there is an update in its system or in the process of the job submission, then it pushes the update to the middleware. But middleware is having the update. But how the updates that it has received from the backend system in the middleware side will be given to the client. That will happen through the connection that is open from the client to middleware. Okay, so it will be like this. So whenever it has received an update from the backend system, it pushes the update to the client. Client is not going to poll anymore. Okay, it just opens a connection to the middleware, and into that connection the middleware will be pushing an update. Whenever it has received an update from the backend system, it is going to push that update back to the client system. Okay, like this. Okay, whenever it is receiving an update from the backend, it is going to push it to the client on the connection that it was opened specifically for that client. So that is how it is. Okay, the SSE means the server sent events. So in this case, only the server is going to send that information to the client, or going to push the updates to the client as an event. Okay, it's not the client is going to poll for it, for the updates. It's only the server is going to send the updates as events. Okay, once the updates are completed, the connection also will be closed to that particular client. Okay, so this is the thing about asynchronous communication, the server side events approach. And that's all for the day. In the next video we will start with the introduction of the application that we are going to implement to do this asynchronous communication with the SSE servers and events. And we will also start with the workspace setup, and we will also discuss about the plan and the different steps that we have to, different layers that we have to implement in order to do this application or project. Okay, that's all for the day. Thank you for watching. Please give it a like, share and subscribe to my channel. Thank you.